All right, exam 4, problem 3. We have a bullet, and it's moving along at 672 meters per second, and then it hits and passes through a block resting on a frictionless table, and after the fact it's moving at 828, so it goes from 672 to 428, right? And it's this 700-gram block, and the question is, what is the resulting speed of the block after the fact? All right. So here's the approach to this. This calls out for, it's a collision. It calls out for conservation of momentum, right? Since it's all in the same direction, and so we know this to be true, right? The initial momentum equals the final momentum. If I really wanted to be proper about this, I'd stick in a vector, right? But since everything is along the axis here, we can drop the vector notation. Everything's in the same line. There's no momentum off axis. All right, so momentum beforehand, right, is the mass of the bullet times, let's see, yeah, I'll just go with small b. Mass of the bullet times the initial velocity of the bullet is going to equal to, after the fact, mass of the bullet times the final velocity of the bullet plus mass of the wooden block times the velocity of the wooden block, right? So now the momentum that the bullet had to begin with is distributed among both objects, because the block had no initial momentum because it's sitting still, right? All right, so we have 0.0052 kilograms times 672 meters per second equals 0.0052 kilograms times 428 meters per second plus 0.7 kilograms times the velocity of the wood. All right, because the only thing we don't know here is the velocity of the wood. All right, so pull up Excel. Let's do some calculations. So 0.0052 times 672 minus 0.0052 times 428. That's the change in momentum of the bullet, and we're going to divide that by the mass of the block, right, to get the final velocity of the block. So the block is cruising along at a hefty 1.81 meters per second. All right. So what is the resulting speed of the block? 1.81 meters per second. The reason this is so small compared to the bullet is that the wooden block weighs more than 100 times what the bullet does, right? So it makes up for, in terms of momentum, since momentum is mass times velocity, most of its momentum is due to its mass, not its velocity, in terms of this problem. All right. Part B. What is the speed of the block bullet center of mass? Okay, so where's the block? Or where's the bullet? The bullet is at velocity of the bullet times time. That's where the bullet is. The wooden block is at the velocity of the block times time. All right, that's where the wooden block is. And we now have all of those, and the velocity of the position of the center of mass, right, is 1 over the total mass onto mass of the bullet times the position of the bullet plus mass of the wooden block times the position of the wooden block, right? So this is 1 over, I'm going to go ahead and put this MB plus MW onto MBVBT plus MWVWT t, right? That gives us the position of the center of mass at any time. And what is that? What is the speed, right? So the velocity of the center of mass is just dx center of mass dt, right? So we take the derivative of this with respect to time. Since we just have time, we're linear in time here, we end up with this being mb vb plus mw vw divided by mb mw. Whoop, plus. And that's the velocity at the center of the mass. We put in the numbers. 0.0052 kilograms, 428 second, right? Plus 0.70 kilograms, 1.81 divided by 0.700 kilograms plus 0.0052 kilograms, right? All right. Let's figure this out. 0.0052 times 428 plus 0.700 times 1.81 divided by 0.7052. So 4.95 meters per second. That is the velocity of the center of mass of the bullet wood system after the collision. All right. If for some reason you wanted to figure out the velocity of the center of mass of the system beforehand, then you'd use the initial velocity of the bullet, and the velocity of the wood initially is 0, right? So then the velocity of the center of the mass just comes down to mb vi over mb plus mw, right? So if we looked at the initial center of mass, that's just going to be mb vi divided by mb plus mw, right? So 0.0052 kilograms, 672 meters per second divided by the 0.7052 kilograms. And we get 4.95, right? So, or 4.96. Why? Because if you look at the object that is the bullet and block together, there was no collision, right? All this is internal stuff that happened, and the center of mass of this system continues to travel at the same rate because the collision was just an internal change in state, not an external change. All right, that's it for problem 3.